Afternoon, guys. Wanted to kind of just do a little quick video with you and just review some of the stuff we did on our test today. Overall, the test results were not horrible. Wasn't crazy about a few of them. I think some could have done better. But what I want to remind you of is like with quizzes and tests, these are great opportunities to look back over them and see where we're lacking and build on that. We should take a poor test grade and say, oh well, I just didn't get it, I'm gonna move on. No, those are probably the best learning opportunities that you could ask for. So in light of that, what I noticed is I saw some things on the test that we need to really look over. So take this as an opportunity to learn. Don't just go, oh well, that's it. So I want to the ones I saw that really a lot of y'all did poorly on was the factoring. Y'all still are not. I'm still not seeing y'all showing the ability to look at a problem and know what type of factoring to do. For instance, when I see a quadratic like this, when I see a quadratic trinomial, my knee-jerk reaction is I'm factoring this thing down into two binomials. That's the knee-jerk. Some of y'all was not catching on to that. I will say I was very pleased to see that you, if you had like I don't know, let's just say it was 2x. I drilled it in your head. You know to look for a GCF, which is very good, but from there you're not looking further. You're not. So let's take this one. So that'd be 2x plus 2. So now this one actually will not factor any further, but you should start when you see a quadratic trinomial like that. You should start going. Things probably won't factor. Now, this particular one will not factor any further, but will not be the real numbers anyway. But this, y'all were missing that. You're missing when to, or what method to use for factoring when you look at a problem. So second thing I noticed is that we remember in our last class we discussed at the end of class about how factoring is just the mechanism. It is the process we go through to help us find the roots of a quadratic. So we went through and we discussed how when we're looking at a parabola, we all know graphically we know the roots are there with the x-axis. And if you'll think back really hard, it is like kind of toward the latter part of the class, I started showing you how when you have a quadratic, it's not sitting saying y equals this. When I want to know the roots, I say, all right, let my y be 0. And then we discuss, okay, why are we letting y equal 0? What does that even mean? And if you'll recall, I showed you, actually, y'all showed me, every point that's on the x-axis, the one thing they all have in common is the y-coordinate, and the y-coordinate is 0. So I'm saying all that to say this. When on your test today, by the way, I've been saying test for about the last 4.5 minutes. I meant quiz. Okay, so quiz. I meant quiz. So before I get any freaked out, hate mail or anything like that, it's quiz, not a test. So when I'm looking at like number 7 here, for instance. When I see a quadratic trinomial like this, my knee-jerk is to say, oh, they're telling me find the roots because it said equal to 0. Normally it's y equals, but now it's 0 equals. So I know I'm trying to find the roots of this quadratic. Now, you can go through and graph it and all. If you have a graphing calculator, if you don't, you have to. Well, for now anyway, you have to rely on factoring. So I'm looking at this. I go, all right, trinomial. I know this thing is going to end up being two binomials, and they're going to be set equal to 0. So the a value being 1. If you'll remember, I showed you that you can say, all right, 18, -9. So two numbers that multiply and give me 18, but they add to give me -9. And as we would probably figure, so we go through 18, so it's 18 and, oh my gosh, I can't write today. 2 and 9, 3 and 6. I've listed all my factors. 3 and 6, right? And they're both going to be negative because they have to add and give me -9. So x minus 3, x minus 6. So I've got the two factors set equal to 0. So when I'm finding the roots, I'm saying x minus 3 equals 0, x minus 6 equals 0, and I'm solving both of these for x. So these two right here are my roots of this quadratic. Now to paint the picture for you, here's what I'm talking about. At 1, 2, 3, 4, 5, 6, 7, 8. Okay, so at 3 and 6. This quadratic's doing something. This quadratic is doing something like this. Now, I do know that it is smiling because I know it's a positive, right? If it was negative, it would be frowning, and it'd be going for those points. So that's kind of a side point, but I figured I'd just bring that to light. I don't necessarily know where the vertex is because I hadn't gone to solve for it, but we don't have to do that. So on those other, so we had, and I'll even show you. So I worked out number 7 right there. So these next two right here, we had to consider the GCF. We had to consider that, and then we had to go through and factor. Now, I'm going to work out. I'm going to work out number 9, and I want to show you a little bit about it. Okay, so here we go. I'm going to erase. Okay, so rule number 1, you look for the GCF. 4, 30, and 50, they all have a GCF of 2. So I have 2x squared minus 15x plus 25. Now, something I saw y'all doing was, he's like, well, that's it. That's all it can be. No. You can go further, right? So this, now, however, notice my a value is not equal to 1. My a value is bigger than 1. Now, I'm pretty sure at some point there's a fellow mathematician and a math teacher that might look at this and go, oh my God, he's showing me this. He's showing this method. The bottoms up method is what I'm referring to. Let me make a little disclaimer here real quick. The only reason I'm showing this is because in the interest of time, what I have to cover and the end goal is, at this point, I'm trying to teach you how to find roots, and I'm teaching you and trying to move on. If I sit and if we do the guess and check thing, it can get very lengthy and we can become so overwhelmed that I might lose you down the road. So I'm actually thinking of for my students' mindset, be like, I do not want to stress them so bad that they just totally check out on me from here on out. Like, well, that factoring right there was hard, so therefore everything else he showed me is going to be 10 times more than that. So my disclaimer is, the reason I'm using the bottoms up method is because I want to to be able not to get bogged down in all the particulars of the guessing and checking, but to make progress. That's the reason for it. Some might argue with me. If you don't agree with that, that's okay. I respect your opinion, but I'm the one making the video, so that's what I'm using. Alright, so the bottom's up. Now let me tell you, you have to remember each part of the algorithm. If you forget one part, screw it up. So here it goes. I take the first number times the last, so 2 times 25 is 50. So I have a new trinomial here. So I'm looking at numbers, multiply and give me 50, and give me negative 15. So obviously it's negative 10 and negative 5. Okay, so I have x minus 10, x minus 5. Okay, and this 2 is just kind of sitting off there to the left. So in class I use this, and it's a shaky analogy, but it kind of give me a little grace here. When I start multiplying by 2, I've kind of changed this expression. It's no longer the same because I've changed it. Now to revert it back to its original state, I have to undo the multiplying, which would be using division. So what I'm doing is I'm referring to this 2 right here. I know there's a 2 right here that's just kind of hanging out. This 2, I'm dividing by that 2. And in class I showed y'all, make sure these reduce. 10 over 2 is 5. I showed you in class the other day about the whole least common multiple thing, why I can do this. The math is sound. I can rewrite this as saying 2x minus 5. So this right here is the factored form of this original trinomial. If you want to check that, redistribute this 2 into right here, then take these 2 and FOIL it, voila, you're there. Now, I want to find the roots of this thing. So I got to take each prime factor, 2, x minus 5, 2x minus 5, and I got to set all 3 of them equal to 0. So you're going to see something weird happen right off the bat. You're going to see 2 equals 0, x minus 5 equals 0, 2x minus 5 equals 0. So you got 3 of them here. This one, for the time being, because it's just 2 constants. The reason I say time being, when we get to polynomials, you can actually have 3 or 4 real roots like that. So it can happen, but being a quadratic, this one, it actually just kind of falls off the face of the earth. But right here, there's your 2 roots right there. X equals 5 and x equals 5 halves. That's your 2 roots. So if there's anything I could give you to really practice on, drill on, in my Google Classroom, I have, and they've been up here all week, there are some practice for factoring trinomials that would be a great benefit to you to go through. It even has, like, it's the CUDA software. We've used those sheets before in class, like for practicing in the past. I would advise you go work through some of those because it has the answer key, so you can check yourself. And make sure you're solid on the factoring. It's really important that you know how to do that. Being able to factor trinomials, quadratics, and all this stuff, quadratic trinomials, is really important that you understand the process and you understand the concept, because it's going to help make a little more sense when we get over into polynomials. So I think, give me a moment, let me look at this again. I think that, there's one more I want to run through. So we're at what, 14 minutes and 27 seconds. I really do try to make my videos short, but sometimes it just it's just the way that it is. I guess I just got a lot to say. And I'm particularly looking right here. I just want to show you these down here, 11, 12, and 13. Now, 11 and 12, we've done a lot like that. That's those difference of squares problems. This one is what's called a perfect square trinomial. Hadn't hit on this one a whole lot, and I'll tell you one reason is because of time. But I'm gonna explain why I didn't necessarily hit this one particular at this time is for this reason. You have this at your disposal. I can still go through this thing and use the regular factoring methods that I've shown you. Now, GCF, there is none. So you got 36. Okay, so it's negative 12, 36. So it's obviously negative 6 and negative 6. So x minus 6, x minus 6, divide by your 9. That's 2/3. 2/3. So you got 3x minus 2. 3x minus 2. Okay, so you have a method that will get you to this point. Now, if any of the fellow math professors and all are watching, you're going to be like, that is horrible. Why would you? Just so you know, I am actually going to show them this. I'm going to show them that I could actually say square root of 9x squared is 3x. Square root of 4. I'm sorry, it's 2. There's a minus in the middle. And they can do it that fast. I am going to show them that. I promise. But in the sake of time, just because I didn't want to get bogged down too much, teach them one or two really efficient ways that work every time. Then I can build and show them the special cases. Because once they understand taking this and getting to here, and they go, wait a minute, those two are the same. I can rewrite it like this. Once they see that, I can go back and I can start showing them the semantics. So that's the reason why I'm doing that. Some may agree, some may disagree. That's okay. You can do that. Free country. Dang it. So I think that is all I really wanted to go over. So I'll just leave you with a couple of thoughts. One of my old coaches, trainers, he always told me that you learn more from your losses than you do your wins. So if you didn't do too well on this particular quiz, take that to heart. Is that you have found some weak areas in your understanding. Now you know what to focus on. So take your poor performance on a quiz and go, now I know what I need to focus, and I can come back stronger when it's time to take another quiz or another test. So be encouraged with that. Life is nothing more than a bunch of learning, and guess what? You're gonna fail a lot in life. That's just part of it. I do it quite often. So be encouraged. You're not dumb. You can do it. So y'all have a great Friday, and God bless. Bye bye.